sharing it with you all. So whoever they want, you can take. The next generation conversational system is nothing but chatbots. Chatbots you can build with a single agent, multiple agents. So chatbot is not a new, AI is not a new. AI started in the year 1957, right? So now we are implementing in a hands-on level, right? So but theoretical approaches were there before, right? So now we are implementing it in a hands-on level, right? So all the approaches were there in the 4 decades, 5 decades. We are implementing it right now. Right? So industry used to call OEM, followed by all the other than idea, all other industries have started moving towards automation. Right? What do you mean by done by 10 people? Now it will done by the one machine. Right? Now this industry, all the repeated works are made it as automation right now. All construction industries, automobile industries, defense. So what they'll do, one side we may say AI may not destroy our jobs, but literally we are doing that. Now this project we are doing, when we complete this project with the current customer, they are going to remove 12,000 employees from each plant by the automation. So that is what we are into, but at the same time, other side, the employment ratio is increasing, those who are highly skilled in terms of development, right? So that matters. EY is one side is doing high layoffs. The who's very good at Python with AI skills, right? So that is how it is happening. So you identify your skill and map, align your skill with the current technology. That matters. So quickly, I'll move on to this. So next, sorry, I'm moving here. So this is myself. So thank you. So next we move on. We'll move on to the next slide. So I thank AICTA team for inviting me as a keynote speaker. Thank you. So next slide. So what GGS, I am representing GGS, what GGS do? So we are into aftermarket segment. Aftermarket segment is something you may not heard of. So suppose you take a vehicle, you buy a car, Renault, or whatever the car you buy. So the car, the production will start from R&D production. Then once car has been sold out, after sales, there is a segment called aftermarket. If I am buying a car i20 sports, then I am buying today, tomorrow I met an accident, where will I take? I will take it to service center, right? In service center, you think of i20. i20 car, I know how to repair it. Because I recruited some ITA guy, technician guy, dealers who's done nearby, I'll hire him, he'll do all service. Think about hire trucks and buses. Same A100 car, RD car, right? So all other higher trucks, buses, if you met an accident, how do you repair it? Whether the technician knows how to repair, how to remove engine, how to repair oil leakages, kind of things, it may not know. So there is a segment called aftermarket. There it works on 4 different pipelines: parts, service, training, and diagnostics. So we do solutioning on all these areas. So competitors are like a McKinsey, Deloitte, Caterpillar, Genpact. They are all into this CAT. So they are all into this aftermarket segment. So we are into the industry the past 40 years, completely US driven. So we are the competitor technology, aftermarket service, technical publications, and maintenance. When you buy a car, you will see, when you open a car dashboard, you will see manuals, right? User manuals. Similarly, there are a number of manuals: warranty manual, bulletin manual, troubleshooting manual, service manual, training manual, wiring manual, special tools. There are 27 manuals are there. We do develop those manuals. Previously, one manual is developed by 200 SMEs. Subject matter experts will be there in each plant. You take tar is done by us aftermarket. So you take any car, so the manuals are prepared by different SMEs. So there are a lot of dependencies. If you want to remove tire, you cannot remove with your knowledge. What manual says you need to do. How to remove engine, how to remove clutch, wire, everything will be there in the manual. That is prepared by us. So we are done all the OEMs except Kia and Honda. We all are our OEM, I mean customers, whatever the car you see in the road, we do aftermarket, right? So we are into automotive, commercial, we do provide solutions. Now we are preparing manuals through AI, generative AI, content generation completely. Previously, it will take 6 months to create a one manual. Now we are doing it in 7 minutes, 700 pages, 600 pages. Such massive automation. So we did commercial vehicles, aerospace. We are into completely into aerospace and defense, military. All the Russia's recent fight aircrafts aftermarket done by us. In Bangalore, HAL, we are closely working with Government of India, HAL for the past 15 years. Constantly, so these CMOs are customers. We are into automotive. Mercedes-Benz are prime customer for the past 25 years. Ford, Mahindra, Suzuki, Chrysler, Johnson Control, Tata in automotive. Aerospace, we are closely working with HAL, Boeing flights, aftermarkets and everything. Same military, we work with Boeing in HAL. Two-wheelers, we work with all. I am close now. I am heading Royal Enfield, which is a part of Volvo and Eicher Group. So they are joint venture. Royal Enfield project, then Mercedes and Eicher project. Just I am taking care. So Daimler, as you know, Daimler is a parent group of all this Mercedes-Benz, Fuso, Frontliner, all are comes under Daimler group. Now they are dividing into separate venture. So these are the segment we are working on aftermarket segments, right? Where more money lies in, right? So this is what we are into. Now we do automation for all these segments now. So now this is what my agenda, where when you talk about automation, these are the technical jargons like GenAI, RAG, right? So multi-model RAG, chunking, embedding, vector search, LLM, retrieval, content generation, then followed by AI agent, agentic AI, agentic RAG, multi-agentic RAG, then how do you evaluate your LLMs, then what comes at the last, prompt engineering, fine-tuning. So this is the current industry, the technology which is ruling the industry right now. So if you know all these things, then you can do anything, right? So let us move on to the topic. As you all know, so for this, I directly jumping into GenAI. So for prerequisite, as you know, the AI universe talks about AI, ML, deep learning, NLP, and computer vision, right? This is a mandatory for this GenAI universe, right? So first of all, what is the AA and ML? Any students? Simply you can say. AA, you are from college or schools? So what is an AA? Can anyone simply tell? Not bookish definition. What do you simulate? What do you simulate?
Sir, we simulate a brain according to me.
Whose brain?
A super brain that has a lot of information.
Whose super brain?
Maybe I cannot define it properly, sir, but as per my understanding.
What do you mean by super? It's a human super or machine super?
A machine super brain.
Okay.
So it's as to put in simple words, it's like a 5-year-old kid who knows nothing, and we feed it with data, and then it will start working on it in spectrums which we miss out.
That is your training the machine. That is machine learning.
Yes, sir.
What is AI?
Beyond, to put it out, it's like after machine learning, after we train it, AI is something that thinks on its own.
Machine learning is a subset of AI or AI is a subset of machine learning?
Machine learning is subset of AI.
Then your answer is ulta. See, very good. Sit down. So simply you can say AI is nothing but simulating. The simulation is a right word. So I appreciate that. So simulate meaning we are simulating the human intelligence, right? That's all. That is a AI. You forget about all these bookish definitions. I want to simulate what humans do. I want to make machines to do, right? So suppose, as you said, you want to train the data, then machine needs to take decisions. See, so how I am thinking like you think. I am seeing a person sitting on the wall, in the 5-meter wall. Okay, he jumping from the 5-meter. What do you say? Whether he'll get an injury or not? 5 feet, you may not get an injury. But he is jumping from 50 feet wall. Will it get injury or not? Yes. How do you say? Yes. Some case you are saying no. Why? How come? He is jumping from multi-storied building. Will he get injury or not? Definitely that fellow will die. Macha setanda, right? So he will die. So how do you say that? Our brain, right, is trained accordingly, right? So similar kind of incident we have come across in our life, past days. So say 5 feet abdina, we will say this is where we see this is not too much of what do you say, vulnerable. So he will just give it an 80 meter, he can 500 meter he'll get, because our brain is trained accordingly by seeing such incident in our earlier life. Similarly, you load your data set to a machine, train the model, make machine to think and give the decision. That is what machine learning is all about. No. I am giving a fish, asking like you say what is the kind type of fish? You say fish, but break fish to 10 or 50 pieces. 1 out of 50. Will you say what's it? But this is a fish, because again our brain is trained by the most. Then you need to train the models and feed and say, right? So it may answer for the 90% of images. It may not answer for the 10% of images because of training. That is what machine learning is all about, right? Whatever humans do, if you want to make machines to do, that is artificial intelligence. Whatever humans able to take a decision, if machine takes a decision, that is what machine learning, right? So you are thinking, right? So whether he will from 500 meters building, if I ask such question, you are taking some time to think and saying answer. You are taking some time to take a decision. That is called deep learning. You cannot take decision in one iteration. You need certain round of iteration. That is what we used to call deep learning. It is a layer artificial neural network with more hidden layers, right? That is what deep learning is all about, right? Say machine able to, human is able to speak. I want to make machine to speak. What is that? NLP, right? Human able to see. I want to make machine able to see. What is that? Computer vision. Human able to walk. I want to make machine to able to walk. Robotics, right? I want a human able to pick this item. I want to pick and place by the machine. It is cyber physical system, right? So everything, human able to taste this water. I want to make machine to able to taste this water. Edge analytics, So everything running around a human. We want what human able to do, I want a machine able to do. That is what AI universe is all about. Nothing is new. You don't want to mark up any bookish things, right? So Gen AI comes into picture when you combine NLP with the computer vision. NLP, natural language processing, comes with the linguistics. We are able to speak, we are able to think, we are able to convert text to speech, speech to text, everything. That is NLP. When you combine NLP with the computer vision, you can say it is generative AI. Gen AI, it is not even creating a content. It is a conversational system you can create. That is chatbots, enterprise chatbots. Right? Now you go any website, you take any now even simple gas booking nowadays we are doing through chatbot. Yes or no? Yes. Right? So your banking website, wherever you go, there is chatbot is now doing a help. It reduced half of the work. Basic question it will answer. Previously, the what where we go to website, we'll go down the page, we see FAQs. What is the questions frequently accessed question? We'll see those answers. Now tradition has changed a little bit into an automation. Right? So what they are doing? Where is those data? How is what do you say? Huh? Data, yes, obviously. Without anything, you can run an organization, but without data, you cannot run an organization. Why this become huge industrial revolution is happening only because of data. Data is growing like anything. Yes or no? In 2020, 2019, in WhatsApp, right, 1 minute some kind of data is being generated. Now it has become triple the time, double the time. Right? Instagram, 1 minute, 7,000 billion swipes are happened. Now it is 10,000 billion swipes are happening. Think about we communicated data via normal SMS, then we moved on to images, then we moved on to voice, then we moved on to images, memes, GIF. Now we started sending voice. See the data growth. Where are you going to store those data? How are you going to process those data? 1 minute in Facebook, 7 billions of terabyte is being generated. Think about 1 hour, 1 day, 1 month. How are you going to process those data? Where are we storing data centers? Where are those data? When you click Instagram, 10 years old image, it immediately comes up with the image. It never says, Acha, this is 10-year uploaded image, wait for 5 minutes. Did it say like that? No, it immediately gives an answer. Yes or no? Some kind of optimization algorithm is running at backside. Right? So this are all running around the data. That is what these technologies are came to an existence for data processing. Right? Next slide. So now, next 1 hour, I'll be talking about this primary goal, how to develop one enterprise chatbot, right, with the technologies. So my deliverables are, so this enables your seamless integration. It implements the intelligent agents, provides high accuracy, robotic, robust guardrails, and AI ops. You started with ML ops, DevOps, now it is AI ops, AI SecOps, AI FinOps, right? So we are focusing on all these. Developing is very easy nowadays. Now governance is matters, right? Security is matters, right? So, next slide. Next slide. Next. So this is what I was talking about, right? So these are the layers. Next slide. Definitions. What is a Gen AI? How this Gen AI was? What do you mean by Gen AI? What is Gen AI? You people are using lot of LLMs, right? Gemini, Chat, Claude, Perplexity, right? Gamma, right? There are number of LLMs. Are these are all GPT based model, transformer based model. What does it mean? GPT. GPT stands for G stands for generative pre-trained transformer, right? It always creates a response, text response. P stands for pre-trained. What are we pre-trained? Because we will say GPT is 4.0 is 175 billion parameter. It has 175 billion parameter. Right? Now it has become 1 trillion parameter because that is pre-trained on billions of parameters. Right? Similar test cases data has been loaded, trained on the specific model. That is what pre-trained. When you say transformer is architecture on this GPT. Previously it's a encoder based, now it is a decoder based architecture. Previously it's a BERT model, now all the LLMs are transformer based LLMs, right? Transformer is a ML model, right? So that determines your different probabilities, right? So that is what GPT transformer. When you say chat GPT is nothing but LLM based chatbot, that's all, nothing else, right? So when you say chatbot has different meaning. You can develop simple chatbot, complex chatbot, enterprise chatbot. So everything data matters, right? Suppose now all the Aishwarya Fertility Center, Aravind IVFs, if you see, go and see their chatbots. You ask any disease, they'll give you solution, tablet, prescription, everything. Because they are giving their data set in a simple one Excel format, right? You ask your disease, they will suggest you tablets. That is simple data set, simple chatbot. Think our chatbot, what we did. We are developing an enterprise chatbot. We are creating a manuals for every car. We have almost 500 plus manuals. One language, English, we are converting into 14 different languages, 14 domestic language, 22 foreign languages. Each manual is 200 to 700 pages. Think the data set volume, 34,000 manual will come for one car alone. Think about Omni, buses, trucks, high-end vehicles, Scania, all this roller, Ashok Leyland, Scania buses, kind of switch mobility. These are high-end trucks, complex. There are more use cases might come. Then training manuals. We train them in AR, VR. Defense, we train them in AR, VR. Simulator, flight simulation we do. Then think about CAD images. Every car, part by part, they will give a CAD images, 3D images. Each file become 4 GB. We optimize 4 GB into 400 MB without any single loss. We even compress to 100 MB because the image, the car image should be loaded into a web application without any time delay, or else latency will happen. So there should not be loss also. There are compression, you might have studied it theoretically, lossless compression, loss compression. Right? We do that by reducing the polycounts. So this is the complexity of the chatbots. We give unstructured data, 7,000 PDF files, right? 700 videos, 800 book content. So these are the input to the chatbot. Think then how we take decisions. Parsing, ingestion, everything so matters. So by default, agents will come into the picture. You cannot play with RAG and model things, right? When you say Gen AI, these are the three terms. Always keep it in mind. One is the data is very important, as I said. Second one is compute engine, right? That matters. Third one, what type of architecture we are working. If you are good in this three triangle, you're in a good place in future. You should be very good. You should know architecture or a data side or compute side, chip manufacturing side. So this is very important. This is a transformer model where we use it for all your GPTs. These are different transformer LLMs these are the different transformer based LLM. Just I did a comparison. GPT 2, 3, 4 so delivered by OpenAI, decoder only. That's a transformer architecture. See, all are transformer architecture, GPT based. Llama, Mistral, right? Then Falcon, Gemma, then finally Claude, right? So these are all your decoder based your architectures, right? All transformers. You should know how transformer works. When you attend interview, only LLM, they'll ask, what is the LLM? What is the architecture? What is the core component of any Gen AI? Data, computer architecture. What architecture? Transformer. How transformer works. This is the encoder, that is decoder. How positional embedding is happening, how data is coming to the embeddings. Again, how we are converting, how response is being generated at the other end. So that is what transformer is all about. So next comes the RAG. So RAG is all about, right? So there are LLMs produces hallucinations, right? right? If I ask LLM to create a room with there is no elephant, you ask some GPT, I want to create a room in a graphics with where there is no elephant. My prompt is very clear, but it generates with elephant. So you ask something that you come across many scenarios. There are hallucinations happen in GPT 2 and 3. Now it's fine-tuned prompting has been done. So there are, in order to avoid hallucination in terms of errors and bias. In order to avoid hallucination, they introduced a RAG-based approach. What is a RAG? It is a retrieval augmented generation. We retrieve the content, we augment it, then we regenerate. That is what RAG architecture is all about, right? So this combines retrieval systems with generative AI to provide LLM with the relevant context. So previously it may not understand the content, it will go with the context-based retrieval from the knowledge base. Go back. So this reduces, see, when you ask questions, it will go to retrieval model, then it searches for its knowledge base, then it retrieves the relevance. It will understand the question, context, it will go to knowledge base, it retrieves the relevant document, then it will augment it. The retrieved content query with augmentation will happen here. Augmentation in terms of improvement, enrichment of the prompt will happen here. Then it will give it to the LLM. Then LLM generates the content. This is what the role is all about. The RAG it works. So next slide. So that is what retrieve, augmentation, and generate. So retrieve meaning the system searches the most relevant document. Augmentation, what it will enrich the prompt by adding some retrieved information directly into the input. Then finally, that more context, relevant context will be given to the LLM for content generation, right? So that is what RAG works. Here there are different phases will happen. Ingestion will happen. First, we need to assume the scenario like I'm giving 7,000 PDFs. I want you to train those 7,000 PDFs, put it into a cloud. Then when I ask question through chatbot, it should answer. How will you do? Assume this is a scenario. I want you to try. Assume 7,000 PDFs. It is a medical PDF. Different disease, different solution, different medicines. All the details are there in your hand. I'm given a medical based documentation. I want to create a medical chatbot. How will you do it? Will you load all the PDFs directly to the machine? You cannot. How will you do? What is the approach you do? Think this scenario and run throughout the presentation. How will you do it? Any general approach? Huh? What do you mean by speech? No, my question is, I have given a document in your hand. I want to build a chatbot. You train the model by using these documents. Then if I ask question something, what is the medicine prescribed for child autism reduction? Then it should give some prescription. What is the best medicine for the cough, cold? Something you ask, it will give you. So how do you do it? That is what RAG will come into the picture. So what we'll do first, we'll do the indexing. We'll load all the document. Then we'll do parsing, right? Then we'll do chunk the document. The word is chunking is more powerful in RAG. So I need to divide the document into different chunks. We have to break the document into smaller chunks. We call it as information units. Suppose I have a PDF in your hand. PDF has 1,000 pages each PDF. Then I will divide one page, each page as a one chunk. Then each page there will be some images will be there. Then I need to link that image corresponding with that page. Then I need to do hyperlinking mechanism. That kind of things, right? So then the chunks will be divided. Then the chunks, how do you store it? Next PDF has again chunks. How will you relate with the main topic? 1,000 pages, you have one chunk. How it belongs to a particular disease. So you need to create an embeddings. Embedding is a kind of the tokens, the entire document will be divided into a token. Tokens will be created into vectors. That is assigning a numerical values. That is the embeddings. You need to assign a embeddings to each chunk. Then I need to put it into a vector store. That is called, we call it as an ingestion phase or indexing phase. Then that will happen prior to the rack model. Then it will go to the retrieval phase. Then when user queries, DB side over, I push to the document into the cloud. Now when user queries, what will happen? It will go to the embeddings. It will search for the similar embeddings by similarity search. Then it retrieves the top K chunks. And some prompt you are asking. You are asking some MCQs in the chat bar with the 4 answers. You are asking answer. What's the answer for this question? What will happen? Similar queries already being embedded, loaded. Like your friends might have tried the same questions, right? When you take a placement exams, blah blah. You guys did it, right? So what will happen? It will go and search the through similarity search. It will try to fetch the data from the vector DB. Then it retrieves the top K chunks. Top K, for example, K I am giving a 5. Then it will retrieve the top 5 chunks, 5 answers. Out of 5, what we will do? We apply the ranking algorithm, which is the most similar answer. That answer will be retrieved to the user. So how top K ranking will happen? When top K is being retrieved by the retriever, it will come with the similarity score. Each chunk comes with a similarity score. First chunk answer is C. So that answer comes with similarity score of 60%. Second answer comes with the 90%. Then third chunk comes with 95. The fourth chunk comes with the 99. Then 99 will be the best answer for the respective MCQ. This is what will happen in retrieval space. Now with that answer, if you want to generate any content, right, then it will go to a generation phase, like LLM will come into the picture. This is only retrieval until there is no role for LLM. Then LLM, what it will do? You do some prompting with the query, then it will give it to the LLM. Then suppose you did right nano banana, you uploaded your image, your the amma image, your friend image, you one reference image and your image, right? Query with the context. Yes or no? The reference is nothing but the context. Then your prompt, you give it to LLM. LLM generated the answers, right? That is completely rack model. Next slide. This is what rack pipeline. I am giving a query, right? This is your augmentation phase. First, the documents are chunked. It will push it onto the cloud, right? So, chunk after chunking, we are doing embedding. I am pushing into vector database. Then it will move on to the. It's a vector DB now. Now, when I query, it will go to search for the embedding. Once you got the embedding similarity search, then it will retrieve the query along with the context. It will go to LLM. Then the LLM will retrieve the answer. If you are not okay with the answer, you can do the prompt engineering or fine tuning, pre-trained, whatever you want, you can do. Generally, people won't go for fine tuning. Fine tuning is too costly, right? Always we go with the prompt engineering, right? Next slide. The same one. This is what RAG is all about. Indexing, retrieval, augmentation. Then second slide, multi-model RAG. When you say multi-model, you have a different. The same applicable for text, images, videos, and etc. Right? That is what multi-model is all about. Next slide. Why does RAG matters? One does accuracy is improved. Then it is completely worked on context based. Then it reduces the hallucination. Suppose if it is hallucinates, then it is only reason because of grounding. You are running a question. You are not getting an answer, meaning there are no similar kind of search where in the LLM side. Then what developers will do, they'll add some grounding, that is called ground truth. They will give some sample ground truth similarity questions to the developer backend, then we will push. In My laptop, I have all live demos like see. This is a complete GenAI solution. What we'll do user query, we do classification, then it will go to a multi-agent orchestrator. It has a knowledge base. Over and above, different agents will be there. If it is a text-based agent, we will use SQL agent. Then if it is the unstructured, we will use a RAG agent. Then that will use that is for content generation, we will use LLM agent. So these three are running on the top of your knowledge base. Then finally, it will go on to the response. There we need to take care of guardrails, safety mechanisms, right? Next slide. This is what now I am doing for one document. I want you to do chunking. You can do one PDF with 1,000 pages. You can do chunking. Think about 7,000 PDF. Will you do manually one by one? It will take so many days, right? So what now then this is the time to automation. I need to automate the task, repeated ones, right? That is what we are setting a data pipeline. So say we do data ingestion, processing, indexing. Next slide. That is what we do. We create a structured approach. We create a data pipeline completely by using some GCP services or AWS services. There are Airflow, Dataflow, PubSub, Kafka. There are a number of services provided by Google and AWS, Microsoft Azure. We will use those services. We can create an automation. Whenever user keeps one PDF into the specific location, automatically clock triggers. Then automatically picks the PDF. It will go via this RAG pipeline. Automatically do chunking, ingestion, chunking, embedding. It will push onto the DB. Whenever user queries through prompting, automatically it retrieves the answer, give the answers back to the user. This is what automation is all about, right? I said one use case. We are doing 400 GB file into 400 MB. This is happening for one file, but one file alone it will take 3 to 4 hours. Think about high files. Our people are sitting day and night, it will go batch by batch processing we do. Now we made it as an automation. Whenever the customer puts a file into the specific location, automatically picks it, clocks triggers, it picks it, it will go via pipeline, automation pipeline, 3D, we have purchased, there are a lot of tools, Pixie, Adobe, blah, blah things. It will compress the file, then push onto the cloud finally. Because think, if I keep the same 400 GB file into a cloud, think about the cost. Cloud cost is what basis? It is a pay-as-you-go model, right? Keeping 400 MB, it will come $0.25. If 4 GB if I keep, I need to pay 800 rupees, 900 rupees for one file. So what we do, we compress, then we move on to the legacy data into a cloud. We did all kind of automation, even though I am paying monthly 12 lakhs for AI services alone in my 3 projects. 12 lakhs. Because this I said vector, right? Embeddings is too costly in GCP and AWS. We wrongly chosen instead of Asia, we choose in Europe. The bill went to 24 lakhs 1 month. Customer deducted from our bill. We wrongly chosen region because Europe region is too costly on vector embeddings. Multilingual, we are doing conversion from one language to different language. The embeddings are different. So AI is none of the AI tools are free. It is everything is a costly and pay as you go model, right? So you find out there are few platforms are there, workbenches are there where you can try out few use cases and scenarios that you find out by attending seminars, workshops, so that you will come to know, right? Or else you cannot learn AI in something basic, right? So that is how these things. This is what data parsing. Next slide, parsing. This is my architecture for the current project. Generally, we do parsing. I do checking whether this file has images or not, or text or not. If the file has images, when you do chunking, you should not separate image and text together separately. You need link together. So we need to do separate images. Separate embeddings for the images and text, right? So check for the image presence. If the images are there, then create an embedding for the image. Then separate text separately, then make it generate the embedding, dense. There are two types of embedding: sparse embedding, dense embedding. We create a dense embedding, then store those dense embedding into a vector DB. There are two types of embedding: sparse and dense. Sparse will use the TF-IDF, term frequency, inverse term frequency, whereas this uses back of 25 watts. So we use that, then we'll push it under the cloud. So that is how this. If suppose if you are using hybrid, then it will go with the image separately, text separately. Finally, it will be stored into the cloud. Then you can do the retrieval of top K chunks. So this is a sparsing is happening. Sparsing is like a ETL. So that is the first step in your RAG approach. Second, next slide. So this is what, next. Next comes your chunking. First parsing, next is chunking, right? Chunking, there are different types of chunking. Fixed size chunking, semantic chunking, structural chunking, hierarchical chunking, topic-wise chunking. There are different chunkings. You cannot chunk the file as whatever you want, right? Context will miss, right? So fixed size chunking, what we'll do for each chunk, I can maintain the token 512 to 1024 token, 4000 token, depends on the chunk size. Similarly, semantic chunk, you can understand the context, then you do the chunking. Topic-wise chunking, title-wise chunking. Structural, it is nothing but either it is maybe XML based, HTML based, JSON based. You can go by structural based chunking. One XML is a one chunk, or one FM file is a one chunk kind of things. Next. So in order to maintain the similarity, we always prefer overlapping chunking, because so that there will be connectivity between, like it is like a chaining. For this chunk and another chunk, there should be a common parameters. Suppose first chunk is a 512, second chunk also 512. Out of this 512, 20 tokens are common to these two chunks, so that similarity and context will be maintained throughout the chunk, right? So that is what overlapping, right? So these are different types of chunking, so you can refer it later. Next slide. Next, recursive, sliding. There are so many chunks are there. Finally, one of the chunks are agentic based chunks, decision based chunks. Next slide. Next. So this is how query, when you query, it will go to embeddings. So that all the documents were chunked and embeddings are created. When you query, it will look for the embedding. Once embeddings are found, it will go for the matching embedding. If the embeddings are matched, then it will retrieve the embedding, it will give the response. This is basic chunking and embedding strategy on all your LLMs, how your LLM works. That's what I'm saying now. Next. In embedding generation, this is the embedding pipeline, text processing, model inference, then it will create the vector storage. Next slide. So this is too complicated. So this is your, as I said, sparse, dense, hybrid also there. There are three types of embedding creation. So maybe you can see it later. So next slide. The third step is vector storage. Ingestion, right? I mean parsing, then chunking, then embedding. Fourth step is retrieval from the vector database. How do you retrieve from the vector database? So vector databases are the backbone of any RAG system, like a normal SQL DB, cloud. Here we will use a vector stores. In vector DB, we will store the embeddings. These embeddings are too costly. So it will search for the embedding. If the embeddings are found, then it will retrieve the relevant context to the user. That is what vector DB is all about. Next slide. There are different types of vector DBs are in the market. You see Pinecone, BVH, Elastic Search with KN, Chroma, Milvis, Fias, Pinecone, Vertex AI. These are all your vector DBs. All these are Pinecone is paid one. These are BV8, Milvis, Chroma, Fias. These are all free. You can try out, right? Next. So this is how the vector. So the data is coming from the top, right? Then query. So when you say hi, hello, how are you? The words are divided into the embeddings. The word embeddings. That word embeddings will goes to the. So there is a text, right? So text will be divided into tokens. Each token is represented with the numerical values, right? So then that we will do the embeddings creation with the encoder. If it is an encoder approach, we'll go with linear and RLU. If it is a decoder, we'll go with the transformer approach, right? Then indexing will happen, then finally retrieval will happen. So you will get some, what is the next word in the sequence by using the nearest neighbor algorithms, right? So this is the mathematical calculation, how vector DB works, right? Right, so this is what query embedding, similarity search, then finally the retrieved chunk will be given to the LLM. You are not giving question to the LLM, you are retrieving set of chunks. You are asking some question, it brings top k chunks or 10 chunks it will bring. Then all the chunks are context wise it analyzed. Then those chunks will be enriched. Then that chunk will be given to the LLM to take a decision. Then LLM will understand the context and the chunks and it will give you the answer. It will do summarize your context and it will give you the final answer. That is what this LLM, all the LLM works, right? Next. So next slide. So this is what LLM is all about. Next. What is LLM is all about? See, when you say LLM is a large language model. Similarly, there are SLM also there, small language models. Right? It's a domestic domain specific LLMs. We created our own SLMs, maybe 2 SLMs in office, right? Are domain specific LLMs. Whatever you ask, you can get the answer, right? I made my laptop as a SLM. So when I ask what is today's task, what is the meeting, it will tell you based on my calendar timings, MST meetings, what is my agenda for today and tomorrow. They ask whether we have appointment, it will check my calendar, it will tell you. So we can make your laptop as an SLM. So such kind of things you can do with the SLM and LLM, right? So this is also basic chatbot, right? Which basically understand your NLP, human linguistics. This is how your AI, human performance, handwriting recognition, speech recognition, image recognition. So in between your language understanding came to the picture. That is your NLP. This NLP plays a vital role in your Gen AI, right? Speech, text, and voice. So that is the importance of NLP in Gen AI. Next. So why these LLMs are so important? Because it understands your human language, natural language. That is what LLM is come to the picture for generation of text, images, then for information retrieval. There are popular LLMs, as you know, there are more than this GPT and other things, right? Next. There are different architecture, as I said. One is transformer based architecture, another one is your BERT based architecture or LSTM, GRU, AN and other things, right? So now we are using LLMs, right? Before LLM, there are some model, RNN based models, recurrent neural network models. Then LSTM. What is that LSTM? Long short, what memory? Long short term memory, right? So GRU, recurrent neural networks. So these are all some kind of RNN based models which does the same what LLM does, right? Previously. But only thing is it is unable to generate the long sequence. Also, there is a memory issue, context memory issue. You cannot recollect. When I say hi, hello, how, what should be the next word? It's unable to understand. So a simple sentence is unable to understand. When you go with a paragraph, I'm asking LLM to write a story on XYZ, right? So it may not curate a story on para because of memory issues. So that is what they moved on to large LLMs, right? So that's the reason, right? Next. There are some popular LLMs, as you know this, right? GPT-4. 4 is 1.75 trillion parameters with the multi-model capabilities. Multi-model capabilities meaning previously only you can type a text. Now you can upload an image, you can ask questions. That is a multi-model, right? You can ask through voice. You can upload some voice. You can upload image and you can add your voice in a question instead of typing, right? So those are multi-model models, right? Other notable models also there, PALM, PALM, right? So these are used for medicals. Gemini, Meta Llama, Anthropic Claude, right? So these are various LLMs are there in the market, right? Next. So what is the core components of LLM? This you should understand when you learn everything, right? One is transformer architecture, as I said. Then pre-training. Pre-training meaning each LLM comes with a different set of billion of parameters, meaning pre-trained. Then fine-tuning. Pre-training will happen before usage. Fine-tuning will happen after efficacy is being calculated. Then tokenization is one of the main thing, because when you type a question in a prompt, it will divide the question into a number of tokens. That is the first step it will happen. It will divide the words, your paragraph, sentence into a token, right? When I ask what will be the weather tomorrow, probably something, right? So then it will divide the question, what is the weather tomorrow? It will divide the question into a tokens. It will remove all the filler words. It will take it weather tomorrow is the word. It understand the context. It will go for the DB. It will search the result. Whatever the chunks it tries, it will do similarity search. Then it will do comparative analysis on nearest neighbor. Then it will bring you the result. So that is based on, that is what we call as attention mechanism. Attention mechanism meaning where to give importance to the word. When you say what is the weather tomorrow, weather is the highly given importance, right? So that is what that attention mechanism is being incorporated into an LLM. It will understand the meaning or context of the words. Then the language modeling objective. This is what the core components. Tokenization, generally first what you do, you will convert your text into numerical tokens. Then embedding dense vector representation. For each token, we will give numerical values. Then what we will do, we will allow the model to focus on relevant parts of the sequence. Token after token, you are giving numerical value to each word. Then remove the irrelevant words, is all the filler words, is, was, this, blah, blah. Keep only core words. Then you apply your feed-forward networks, process and transform the information to each layer. Finally, you generate the output. This is what it will happen. Right? When you say how LLM works, you can say blankly tokenization followed by embedding, then apply transformation layer, then you are applying the attention mechanism, then you are predicting the next word token in the sequence by inference mechanism. Finally, you are generating the output token. That's all, right? What it will do after words tokenization, you are giving embeddings, then you are removing all the irrelevant words. Now you have only context words, right? Now you take the first word, second word, compare with the first word. Take the third word, compare with the first word and second word. Take the fourth word, compare with the first word, second word, third word. Calculate the similarity scores. Then you do a ranking, which is the highest in the sequence. That will be the next word in the sequence. Do you understand how it works? How it predicts the next word in the sequence? LLM. This is what it will work. That is what this LLM role is all about. Right. Next. Same, I explained it next. So there are two things, pre-training, then fine-tuning. Fine-tuning, there are different techniques, as I said, supervised fine-tuning. Then we call reinforcement learning from the human feedback. When you try something through chatbot, if you're not happy with the answer, what you will do? You will click thumbs down. If more thumbs down comes, it will go for a human feedback. We'll apply reinforcement learning. Admin will go and take those queries. Why it is a wrong answer? Then it goes down the similarity score of less than 0.75. Then the more grounding will be added to the question. Next time the same question raised by some other location geographically, then it will come with the relevant answer. That is how this feedback mechanism works. Then parameter efficiency model. Here they'll add more smaller modules into the existing layer. They'll add more ground truth. Where are we using this LLM? As you know, content creation, code generation, translation, answering, analysis, also in education. Now in education, everybody started using. Now all the universities are planning on complete question paper generation through AI, right? So meaning what? they'll take all your question banks, they make it as a DB, they'll push it onto the cloud, they'll do chunking, same whatever strategy I told, this is what will happen, if you know technically. Then push it onto the cloud. When questions asked, it will generate randomly. Then it will go for the validation. Always you cannot get 100% accuracy, 80-20. 80% by AI translation, 20% human in the loop, done by validation, right? So that is what is going to happen. Right, next. So leave it next slide. So this they may not understand next. So this is I said explain retrieval strategy. Now finally, as I said, how the content are created, the retrieval chunks are given to LLM like GPT, Claude, Llama, Mistral. Then GPT will get high accuracy. Also, it's used for general purpose. Claude, you can go with the long context and reduced hallucinations. Llama, self-hosted and fine-tunable. Mistral, it work for this efficient for smaller SMMs, right? Next slide. That is so, right? So now what is the difference between, go back. Now what is the difference between this RAG and agentic RAG? Any idea? What the RAG will do? Where agentic is coming to the picture? RAG always retrieves the relevant data from the data source for the given prompt. But agentic, what will happen? When user queries, you can read the point. When the user queries directly to an AI agent for processing, the AI agent uses the short-term, long-term memory. So I'll explain simple. So when query comes, what it will do? It will forward to an AI agent. AI agent, what it will do? It will see the query, understand the context. It will forward to another agent. What it will do? It will look for the tools or APIs or any other mode of stream through which it will fetch the data and it will give it to the LLM. Then LLM will make a decision. So this agent will use a tool as a medium or API as a medium to fetch the content. Then it will give it to the LLM for taking a decision. That is what agents will work, right? You see here. When you say, also there is a difference. Go next slide. Back. This comes with generally retrieval system same, generation system same, plus one more layer is added, agent layer. Because agents here will take a decisions based on the context, right? That is what agentic RAG is all about. Next slide. There are differences. You may ask, what is AI agent and agentic AI? AI agents are simple agents, right? It will do only one job at a time. But when you say agentic AI, it is a collection of AI agents. It will do batch of system, multi-step process, memory, self-correction, everything it will do. Same agents follow the instructions, but agentic system use the planners, executors, memory, feedback, self-review, everything it has. Also, AI agents, it will do repetitive tasks, but agentic agent, it will do complex systems, complex work, research work, heavy work. You may see in ChatGPT, if you buy a pro version, you would have seen there are research. When you say it will, when you type a question, if you want to write paper on blah blah introduction literature survey, it will tell you thinking, reasoning is happening, step by step will happen. Meaning agent is moving on, taking a decision on different stages. It is working on reasoning layers, right? So those are all complex. If you ask that question, it will give you an answer. I'm asking agents to prepare a PPT by Gamma, so it will take decision. It will think. It will go on different iteration. It will think, resonate. Then it will take a decision. That is what this complex ongoing. How do you measure agents? Are they cheap and accurate? Yes, they are cheap and accurate. But agentic system only solves complex problems, right? So next slide. Right? So this is the difference. LLM flow, you know, user prompting, we are giving a rule based, then LLM finally output. RAG, you have a user prompting, then it will go to the RAG setup. It has embedding vector DB, then you are doing a retrieval. augmentation, final output. Then AI agents as an individual entity like a entrance user, you're giving a prompt, it will go in an AI system, it has a chat, it has one database, planning, memory, tools, and reasoning. It will take a decision on its own and will give you the output. When you have agentic AI is a complete system where more agents will be there. If I am unable to answer, then I will redirect the question prompt to the another agent where it is aligned, right? So each agent has its own memory one, then it has a reasoning, then it has a feedback. These are the three stages in your AI agent, right? It has a own memory, it can resonate, then also it can have a feedback loop. Then it will given to the another agent. Also, that also has some tools, databases, feedback, and other things. So this is how this AI agents works. Right? Next slide. So now what AI agent truly an agent? When which agent has a memory, planning, correct tool use, then feedback and collaborations. When you have this five mechanism, then you can say that AI agent is a true agent, right? Next slide. Next slide. See here. So what is the main AI agent will do? When you say agent has several capabilities, as I said, it has its own database, meaning it stores some set of existing knowledge and past response. Then also it has a feedbacks because every result, once you get a result, user is giving a feedback, like in terms of different thumbs up, thumbs down, regenerate. It has all those user responses in their cache memory. Then planning what it will do when user is prompting, it will break the question into a different tokens, right? It has a planning. Then memory, it has its own memory, right? For each agent has its own memory for their respective context. Reasoning meaning it can take its own decision, logical decisions based on the steps which is taken. Tools meaning it connects to the external API functions or services whenever needed. It is unable to take a decision, then it will try to find some tools, API to fetch the data. You see, Claude, if you would have tried, and GPT, if you have tried, if you're trying to generate a document, the document which has hyperlinks, if you might have seen, that meaning it refers some other external tools and API to support your current context. That is what this tool is main role in AI agents. Then suppose this agent is unable to do, then this delegates the task to agent 2. Now this agent has data feedback planning. If unable to understand what it will do, it will forward to this agent. Suppose this is a main agent. I am asking a query in parts related questions. For example, I want a part for I-20 car. Suppose my clutch was broken. I want to find the alternate parts for I-20 car clutch. Then what it will do? It will redirect the question to parts TB. Then or else it will redirect to services TB. It will suggest you where you can do servicing, where that job can be done. So this is the parts agent. This is your service agent, right? So then finally, all the agents are mutually interlinked. They're collaborative agents, right? So you can develop agents through different frameworks, right? You can develop through LangGraph, you can develop through CrewAI, right? So we have done completely LangGraph, completely hands-on hard-coded, right? So how this agents, when you say individual agents uses the MCP protocol, model context protocol to communicate. When you have multiple agents, it uses your A2A protocol, agent to agent protocol, right? So each agent has its own memory and sensory data. This is how it works. So the query is received by the main agent. Then it decides if the query needs stored knowledge, then it asks the agent to refer vector DB. Suppose if the query needs a real-time search, then it will ask the agent DB. The previous diagram, one is stored knowledge, another one here real-time. Real time, it will look for the tools and API to get the data. If the both the agents sends their process information back to main agent, then main agent takes the decision. That is what it will do. This is how multi-agentic RAG works, right? Next. There are different patterns: sequential, parallel, router, feedback, builder, autonomous. We always prefer with the router-based agentic system because it will go from main, it will check. If it is stored knowledge, it will forward to one. If it is you're looking for this some new knowledge, it will forward to another one. Then finally pushed onto the main, it will take decision. Or else it will go to autonomous agent, like your RPA, robotic process automation, cyber physical systems, and finally, this is how the overall process: ingestion, chunking, embedding, vector DB, retrieval, LLM, agent, multi-agent, multi-RAG agent, right? Now, sir, this is okay, sir. Now, how are you going to evaluate the efficacy of a model? That is a very, very important question. So, how do you validate? LLM gives the best answer. How? This is what we call it as a key metrics. Yes, sir. You might have done basic in when you study ML algorithm, supervised, unsupervised. Supervised, you have done precision, recall. Even unsupervised, you have done mean time. What is that? RMT, root mean square, equilibrium distance, right? So there are some metrics you have done, right? So here in kind of this complex project, how do you evaluate? So there are some set of benchmarks are already defined. So we use some set of benchmarking to evaluate your RAG system. We use a RAGAS as one of the framework to evaluate our AI efficacy model. What are we evaluating? We evaluate retrieval quality, we evaluate generation quality, then we evaluate the system performance through different metrics. I'm giving a question, I'm asking a question, I'm getting an answer. How do you say that question retrieval is quality? It is a relevant. How do you validate that all the ingested chunks are relevant? How do you validate all the chunks as the data? Few chunks may not have a data. It may be missed during ingestion. How are you going to validate all these areas? I'm asking some questions, some answer is coming. Before coming, giving the answer to the user, how will LLM decide this is the right answer? How do you validate it at the user end? Just think on development side. Generation quality, how are you checking the answer is relevant? Faithfulness. Then recall, accuracy. At K means retrieval. So 5 chunks I'm retrieving, or how do you say all the 5 chunks are relevant to the question? So these are all evaluated based on that benchmark called RAGAS. We collect similar questions. What is the answer for those questions? Then what is the chunks in the DB? Will retrieve those chunks. Will run the RAGAS setup in server, production server. Then we'll evaluate. Then automatically for every retrieval, how much questions are, contents are quality enabled, relevant, accuracy, everything will be automatically checked. It is automated. You should not calculate by doing a confusion matrix, precision, true positive, false positive, by divided by all these things, blah blah things. These are all automation. Suppose if you receive greater than 90%, then you can say this user is satisfied. If not, it will go for fine tuning. This is how we do evaluations, right? So in the evaluation, if you face something, then call it as a hallucination. That is a separate track. So that's all. So random what last. These are all guardrails. These are all implementation side. So AI generally has a different layers. Bottom layer is infra layer. Then the second one is the data layer. The third layer is your application layer. The fourth one is your presentation layer, what application we develop. Final layer is governance layer. That governance layer covers all these things, efficacy, security. How are you going to, suppose your LLM did some abnormal behavior. How are you going to control your LLM abnormal behavior? How are you going to calculate your guardrails? How are you going to check the hallucinations? How are you going to calculate the drift? Drift is happening in different level, data level, application. How are you going to monitor? What about SecOps? What about FinOps? What about this data? Anything may happen anytime. How are you going to control? How are you going to control it in Gen AI layer? So these are all matters. That top layer is governance. If your governance not in a proper, this entire stack gets affected. So this is what all about complete automation process. When you do automation, you should take care of all these things, right? So this is what technical excellence we build, pipeline setup, multi-agentic orchestration. You should have a retrieval strategies, then you should have advanced prompting. Then you enable your safety and reliability via guardrails enforcement, fallback mechanism, evaluation. Also, we used to call continuous monitoring and alerting mechanism is necessary throughout the project. Then finally, you can have your AI ops into one place. Everything now comes under AI operations in AI, right? So when you focus on all these things, technical, safety, reliability, and operational, finally your product is ready for the deployment. Then you can develop locally in the environment. Then you move on to the production, right? So that's all. This is how this multi-agentic rack for enterprise automations, how we can create a scalable AI solutions. Next slide. So if you want to learn Gen AI, so you can start from this foundation model, important concept, stack you should know, various foundation model you should know, building AI agents, computer vision, some resources. So you should follow this roadmap. Next slide. Then there are some GitHub links are there. There are some Gen AI GitHub links, courses with open source codes are available with notebook files. You can try that. You can try this URL, generative AI for beginners. You can search this keyword in the GitHub, you will get this link. Generative AI for beginners. This GitHub link you will get. You can go the Google Notepad. Next slide. Next slide. This is exercise 12 exercise with Colab open exercise also there. You can try LLM from scratch. That is your GitHub link. You can try this. Okay, next. So that's all. This is AI agents course. So beginner and advanced AI course, you will get it. So this Gen AI and your LLM and AI, all the code. There are a lot of GitHub repositories available in GitHub. You can try follow any one or two repo for your skilling. Okay. So that's all. Next. So for more information, you can follow me on LinkedIn. So the name. So I keep posting internships, recruitment, then other opportunities. You can follow me in LinkedIn, so you can get it. So next slide. Thank you. Thank you for the opportunity. Any questions? I think I overloaded many technical jargons, but try to figure it out. Take any one or two keyword which attracts you. Try to find out. Do digging more on those topics and try to develop some products or application, paper, something, so that it will be quite useful for your career. Thank you. Any questions? Any doubts?
So how we can that you are collecting various data sets, but all the manuals, and you made something like this part be affected, you just go to service center or this part be affected or something like that. So how we can able to make controlling these, like giving some security.
That is what the governance layer is coming to the picture. So what we do, we develop this web application in terms of mobile app, iOS app, Android app. When you go to the service station, you can see the people, the technician, when you take your car, they'll ask you to park it in that proper plane. Then what they'll do, they'll take that OBD device, they'll connect your car, then they'll load it in your tab. Immediately your car 3D model will be loaded into their tab. Then technician, he will ask, what is the problem? There is accident. He will ask, you may say that will buy that memory. Use cases. So what he will do, he will select that software consists of, so it is a kind of security based software. You cannot, it is a completely MFA multifunction. You can choose the what is the problem, severity, low severity, high medium severity. Then he, when he select the severity, he will get a solution. Then he will follow the instruction. He will finish it up. That is not given access to the end user. That access only given to the dealers and technicians. So they will maintain it. Now we are developing a product which is one of the industry ready product. Suppose you are traveling in a highway, your car gets stuck in the highway, but what will you do? You call some the guy dealer nearby by seeing Google or something. He will call you, he will tell you some ideas. Then you wait for 3 hours, 4 hours in the highway. Then one truck will come, will take your car to station. Now that is not going to happen in anymore in the future. We are developing India's first industry ready product. I should not reveal the name, it is going to be launched very soon. So you can yourself, you can do the diagnostics completely. We give solution in terms of AR, VR, in terms of voice, in terms of manuals, in terms of videos, in terms of audios. You have different solutions. Like a chatbot, you can put your problem. You can scan your problem. Suppose you got a fire, smoke from the bonnet. You just take a video, send it to the chatbot. It will give you an answer what you need to do next. Any worst case only, it will be taken to the service station. If not, you can do it by yourself. That is what the future is become. We are moving towards automation. But when you talk about back to question, automation, safety, that application side as a part of DevOps and MLOps, SecOps, we need to enable all those security features in the governance layer itself. So there are many drift may happen. We know only security in terms of passwords. That is not a only level. LLM might be hacked. Yes. Data may be leaked. LLM behave abnormally. Something you may have something like a robo giving some different answers, right? So kind of things may happen. How do you enforce? So everything controlled by services. Those services provided by service providers, GCP, AWS, Azure. They provide set of services. If you want to monitor, there are cloud logging is of the service. Then Airflow is a service. Then cloud functions are there. MFA are there. There are different services are there. Whenever something goes beyond your control, it give an alert. Then DevOps will come into picture. He will start monitoring the services dashboard where it lacks. Suppose my billing every month I am giving 12 lakhs billing. Sometimes due to whenever we do testing, billing goes to 15 lakhs. Alert will come. Your orange alert will come. It crossed more than that, red alert will come. So that monitoring will take place. That is what we are maintaining safety. Over and above 80%, 20%, anything may happen anytime. So that is what we are doing, proper backups, other things we are doing. So DevOps should be in a proper, or else it's very difficult. Any other questions? Okay, thank you.
Thank you, sir, for sharing your experience in industry to our participants. Sir, your valuable suggestions about networking and skill improving towards the development and of product development will definitely help our participants to improve their skills and settle in their career. So you have also given a deep insights on large language marks, RAG, transformers, llama, AI agents, and automation, and more recent technologies, which will help us participants to build an innovative projects in a real-time environment. Thank you very much, sir. So, dear participants, there's an announcement to you all. So you can go with your lunch break, and you can report back at 1:30 here. So we'll be having a project display here. Your projects will be evaluated at that time. So all the participants report back at 1:30. So you can proceed further with your lunch. Thank you.